Hi dear students, this is the fourth module of the subject ME 206 Fluid Machinery. In this part, we will be dealing with some hydraulic systems. In the last part of the syllabus, some hydraulic systems are there, so we will be seeing one by one. The main important hydraulic systems we will see one by one. First hydraulic system is hydraulic ram. You can see in the figure, this is the picture representing the hydraulic ram. You can see a supply tank will be there and a supply pipe is there through which the water from the supply tank will be reaching this portion. So in order to control the flow of water into the this chamber, there is an inlet valve at the end of the supply pipe, and this is the chamber where we can store the water. And within this chamber you can see two valves, valve B and valve C. These two are the flap valves. One is open, one is kept open towards the bottom side, and the other one it can be opened towards the upper side. So once the water is filled within this chamber, this valve B will, this is what is known as waste valve, this valve will close, and at the same time this valve will be getting opened. So initially the valve C will be closed and valve B is opened. Based on the level of the water within this chamber, the valve will be closed and simultaneously other valve will be getting opened. So going into the working, the main advantage of this type of hydraulic ram is there is no external power is required to operate this one. The requirement of large quantity of water with small positive head is there for this one to operate. That is, there should be an availability of large quantity of water at a small head. We don't want high head, but the quantity of water available should be very large. Usually hydraulic rams are used to lift small quantity of water to a greater height. Priority is given to lift very small quantity of water, that is discharge from this hydraulic ram will be very less, but it can be raised to a particular height. That is the advantage of hydraulic ram. And remember, there is no external power is required for this one to operate. So it is used to lift small quantity of water to a greater height and works on the principle of water hammer. The system has a chamber with two flap valves and an air vessel. As I have told, it has a chamber at the bottom portion. You can see a rectangle here. This is the chamber, and two flap valves are also there. B and C are the flap valves, and along with that we can see an air vessel at the top of the chamber, and a delivery pipe is also there to lift the water from the air vessel to the required height. So this is the delivery height, and the water is discharged at this point. So you can see this pipe will be very small in area, so the discharge will be very small only. So coming to the working, what happens is, this is the very high discharge available at a small head. You can see this, only this much head is available. H is the head available. This head will be very small. So wherever in practically we are having very large quantity of water and a small head is able to provide, then we can construct this one. Okay, it's a permanent structure. Now coming to the working, as the water is flowing from the supply tank, the chamber gets filled up and the valve B starts to move upward and suddenly closes. You can see as the water from the supply tank moves to this chamber, the water level in this chamber gradually increases. That will exert a pressure on this flap valve B, and it is finally, once the water is filled in it, that means the valve will close. So that sudden closure of the valve B creates a high pressure inside the chamber. This is what is known as the water hammer. If a valve is closed suddenly, there will be a high pressure generated. So this sudden closure of the valve B creates high pressure inside the chamber, which opens the valve C. So this high pressure causes for opening of the valve C, which is the delivery valve. So once the valve C is opened here, means the water from the chamber due to that high pressure will be entering into the air vessel. As we know, this air vessel is similar to that fitted with the reciprocating pump. So at the upper portion of this air vessel, we will have the free air. So as the water rushes into this air vessel chamber, the air is getting compressed. So initially, once the air is getting compressed, means the high pressure air is stored at the top portion. So once the pressure reaches to the required value, what happens is this high pressure air compresses the water inside the air vessel. That means the valve C is closed and the water in the air vessel is pushed through this delivery pipe to the required height. That is the working of the hydraulic ram. See here, there is no external force applied. Only the water is allowed to flow from this height to this chamber, and once this chamber is completely filled, this valve is getting closed. Due to the closure of the valve, a high pressure is generated inside this chamber. This is what is known as the water hammer. Due to the water hammer, the valve C is getting opened, and the air is the water rushes into the air vessel, and the air trapped at the top portion of the air vessel is getting compressed. Now once the required compression is achieved, or the required pressure is reached by this air trapped here, the air will push the water in the air vessel through this delivery pipe to the required height. While the pressure here is increasing, means the valve C is getting closed, so there won't be any backflow, so water will be flowing through the delivery pipe. So once the discharge is completed, means or the pressure here is falling down, means the valve will that means the flow of water into the air chamber continues till the pressure is high. Once the pressure becomes low, that means the valve be getting opened, so at that time the flow again starts, and this cycle is repeated. This is the working of the hydraulic ram. So once the delivery valve opens, the water from the chamber enters the air vessel and compresses the air inside the vessel. The compressed air exerts a force on the water inside the air vessel, and a small quantity of water is raised to a greater height. As the water in the chamber loses momentum, the waste valve B gradually opens in downward direction, and flow of water from the supply tank starts flowing to the chamber, and the cycle will be repeated. This is the working of the hydraulic ram. Now next one is hydraulic accumulator. You can see the figure. This is the representation of this is the figure representing the hydraulic accumulator. It is similar to the hydraulic ram, but here external power is required. Whenever in a cycle, if the energy is not required, fluid energy is not required, we will be storing that energy in the hydraulic accumulator, and once the energy is required, at that time we will be using the stored energy to the system. That is what is simply happening in a hydraulic accumulator. It is a simple hydraulic device which stores energy in the form of fluid pressure. So this is the device which stores the energy in the form of fluid pressure. So pressure is stored inside the hydraulic accumulator. So once the high pressure is required, pressure is taken from this hydraulic accumulator. Usually it is utilized in lift and cranes, etc., where high pressurized fluid is required. See, for the operation of the crane, we are in need of high pressurized fluid, and also in the lift to move the lift upward, we will be using the pressurized fluid. So all these cases we will be using the hydraulic accumulator. Once the opposite direction, that is if the lift is moving downward, there is no requirement of the energy. At that time the pressure energy is stored in the accumulator, and while the lift is moving upward, we will be using the stored energy from the accumulator. So it is a simple hydraulic device which stores energy in the form of fluid pressure. This stored pressure may be suddenly or intermittently released as per the requirement. Consists of a fixed vertical cylinder containing a sliding ram. A heavy weight is placed on the ram. This is the construction of the hydraulic accumulator. You can see a sliding ram in this one, and above the ram you can have you will be having a high weight kept there. So this is nothing to exert the pressure on the system. We are keeping that weight, just like in the case of the pressure cooker. Over the pressure cooker we are keeping a weight. Like that, a heavy weight is placed over the sliding ram, or the head of the sliding ram. Consists of fixed vertical cylinder. This is the vertical cylinder. This is the vertical cylinder, and this inner portion is a sliding ram. This inner cylinder can slide within this outer cylinder. Okay, consists of fixed vertical cylinder containing a sliding ram. A heavy weight is placed on the ram. The inlet of the cylinder is connected to the pump. You can see at the bottom portion here, inlet is there. Inlet is connected to the pump. Pump will be pumping the fluid into the hydraulic accumulator continuously. So that's why I told there is an external power is required. So once the pump is operated, then only fluid will be entering into this accumulator. So power is required. The inlet of the cylinder is connected to the pump, which continuously supplies fluid under pressure to the cylinder. So high pressure fluid is entering through the bottom portion of the hydraulic accumulator. So if there is no outflow, here you can see an outlet. If the outlet is not required, or the energy is not required to the system, usually the outlet valve will be closed. At that time, the continuous entry of the high pressure fluid is there into the hydraulic accumulator. That means the pressure energy, the fluid level is raised here. So this will be the sliding ram will be gradually moving upward due to the pressure of the fluid exerted here. So it will gradually move upward. See, it is rising a weight also. So equivalent to this weight per unit area, how much is the W by A, that much pressure will be there inside this hydraulic accumulator. So high pressurized fluid is stored inside this accumulator. That means pressure energy is stored here. So the inlet of the cylinder is connected to the pump, which continuously supplies fluid under high pressure to the cylinder. The outlet of the cylinder is connected to the machine, which may be a lift or a crane. So outlet is usually connected to the machine where we require the high pressurized fluid. Usually it will be the lift or crane. Now in the beginning the ram is at its lowest most position, the innermost position. At the beginning there is no fluid here, so the ram the weight will be touching almost to this portion, and the lower portion of the ram is colliding with the bottom portion of the fixed vertical cylinder. So that is the starting point. The beginning ram is at the lowermost position. The pump supplies hydraulic fluid under high pressure continuously. If the hydraulic fluid under pressure is not required by the machine, see, if the machine is not required, if the energy is not required by the machine, so there won't be any outflow. So that discharge valve is kept closed. It will be stored in, so only inlet to the cylinder will be there. That high pressurized fluid is stored inside the cylinder. This will raise the ram on which a heavy weight is placed. When the ram is at uppermost position, the cylinder is full of fluid, and the accumulator has to store the maximum amount of pressure energy. Once the ram is at the uppermost position, we can say that the maximum energy is stored within this accumulator. When the machine, that means the crane or lift, requires large amount of energy, at that time the discharge valve is opened. That means the ram will be moving downward, discharging the high pressurized fluid to the machine. So when the machine requires large amount of energy, the accumulator will supply this energy, and the ram starts to move downward. When the machine does not require the energy, fluid pumped from the pump is stored in the accumulator for the future use. So this cycle is repeated. When the machine is not requirement of the fluid at high pressure, then at that time the accumulator will store that high pressurized fluid. Whenever the machine requires the high pressurized fluid, at that time the pressurized fluid is allowed to flow from the accumulator to the machine. So this is the working of the hydraulic accumulator. So I think these two questions have been asked for the university for several times. So these are very important. So please go through, the notes are uploaded in the Moodle. You can refer the notes also.